I had a question from some people today about a problem. I think it was number 23 in the homework. It's about something called the converse of the Pythagorean theorem. And I don't think the problem actually says this is the converse of the Pythagorean theorem, but I want to talk briefly about the concept. So remember, first of all, what a converse is. If I have an if-then statement, for example, if I say if two angles are right angles, then they are congruent. The converse of the statement changes the order of the if and then parts of the statement, okay? The hypothesis and the conclusion of the statement. So the converse of that statement would be if two angles are congruent, then they're right angles, okay? That statement's not necessarily true, all right? Sometimes converses are true, sometimes they're not. You just have to be very careful of changing the order of a conditional statement. The Pythagorean theorem as an if-then statement would say something like, if a triangle is a right triangle, then a squared plus b squared is equal to c squared, okay? Establish that you have a right triangle, then you can conclude that relationship between the sides. All right, we're going to have a similar kind of relationship here if you flip-flop that order. The converse of the Pythagorean theorem is true. The converse of the Pythagorean theorem, I should probably spell that right, the converse of the Pythagorean theorem says that if a triangle, if a squared plus b squared is equal to c squared, then the triangle is a right triangle, okay? But it goes further than this, okay? So this question here, I believe this is number 23. You can check real quick and see, is this a right triangle, all right? And you could basically just check and see, is 6 squared plus 7 squared equal to 10 squared? And I'll do a little question mark here over the equals because we need to check and see if they're the same. And you'll see that's 36 and that's 49, and that is not equal to 100, okay? So on a low level, this doesn't work in the Pythagorean theorem, not a right triangle. Now, the follow-up from this, you can actually tell what kind of triangle you have if it's not a right triangle. So it could still be obtuse, it could still be acute, all right? Here's the deal. Let's look at a triangle that is a right triangle for a second. So let's say I've got a right triangle with side lengths of 3, 4, and 5, okay? We can check to verify that this is a right triangle. 3 squared plus 4 squared really is equal to 5 squared, okay? That's 25, that's also 25, okay? Right triangle. Here's the idea. If I take that right triangle, and let's say I could pivot this angle here. If I open that angle up longer, you're going to get a longer and longer and longer C side, okay? In other words, if I take my 3 and my 4 and I lock them in place, and I open this up, to get an obtuse triangle, the hypotenuse is going to have to be longer than 5, which means the C side needs to be bigger than what I would expect it to be if I wanted to get an obtuse triangle, okay? Meanwhile, if I take my right angle, and I close my right angle, but I keep the 3 and the 4 the same length, that C side is going to get shorter. Okay, if the C side is shorter than it's supposed to be, then that largest angle is going to be less than 90 degrees because you've got to close that right angle, and it's going to end up being an acute triangle, okay? I think books often make this confusing by writing the statement focusing on a squared and b squared. You don't want to focus on a squared and b squared. You want to focus on the C side, okay? If C is bigger than it's supposed to be, or C squared, the hypotenuse here, then your triangle's obtuse. If your hypotenuse side, if your C squared is less than it's supposed to be, your triangle is acute, okay? So I write it backwards of the way that most books will write it, okay? Most books will tell you, of course, if C squared is equal to A squared plus B squared, your triangle is right, okay? No big surprise there. If C squared is greater than A squared plus B squared, okay? Notice I'm doing the statement backwards, okay? Because we're focusing on the C side. If C side is greater than A squared plus B side, we have an obtuse triangle, okay? And if C squared, if that C side squared is less than it's supposed to be, then you have an acute triangle. Okay, so I want to go back to that one that we had before. Question 23 in the book is going to ask you to classify a triangle with side lengths of 6, 7, and 10. Okay, so we have 6, 7, and 10. And you're not supposed to look at it and guess, okay? You're supposed to actually calculate. Okay, so again, I set it up with C squared on the left because I'm focusing on C squared. Okay, so is 100 squared equal to 6 squared plus 7 squared? Of course, the answer is no, okay? That's 100. And that's 36, that's 49. Does that add up to 85? Okay, so c squared, if this was going to be a right triangle, this side would need to be the square root of 85, okay? And instead, this side is the square root of 100. Okay, so what that's telling me is the c side's bigger than it was supposed to be. That means it's an obtuse triangle, okay? So hopefully that's helpful in helping you identify what kind of triangle you're working with using the Pythagorean theorem.